we'll try and do initially just the strake-based model, and then we'll go on to do the regular model, the level 2 model, where we model all the individual beams. And the mesh that we're going to target, it'll be approximately a 1 meter by 1 meter mesh, and that's roughly the density of the mesh that we'll be generating. So these are the strake endpoints that we want to create for pulling into Maestro. You'd have to create the individual endpoints within Maestro and then start connecting them into strakes and so forth. And for a large vessel, that can be a lot of typing in coordinates, looking things up on drawings to get them and so forth. So that was why we started looking into, gee, wouldn't this be easier to do graphically from a surface model? So we started doing this in Rhino, where we could create these endpoints fairly quickly. And I guess Ming had modified the PLY importer to accommodate more than just points, triangles, and quads. Now the version that he has in Maestro is modified so that it looks for numbers on a line, so that it can also figure out what is an endpoint and what is a polyline telling it which two endpoints to connect into a strake. And one of the files that I had sent was this, how to run this endpoint script. And this ships with Maestro. So if you go into the Maestro models and samples area and under Rhino scripts, it is this export Maestro endpoints. That's the script that's described here. Essentially, it's a collection of lines representing the endpoints, and then you can create a polyline that tells the script how each one of those endpoints should be connected into a series of strakes. So you simply pre-select all of the endpoints, run the script, and then as an optional argument, you can give it the polylines at the end, which will tell it how to connect them into strakes. If you don't, it'll just create the endpoints, and then you can manually create the strakes in Maestro. But if you simply create these polylines at the end, it will go ahead and make the strakes for you, so that when it comes into Maestro, you'll have the full module created with all of the strakes that you defined with those polylines. And you can see at the top here, there were a few extra strakes used for, I guess, creating, in this particular model when it was built, there were compounds along the length of the strake to create braces under that combing. It's the full length of the module, but it's only a single section. So then you simply go in and edit the module to delete that one long section and replace it with as many sections as you want. And in this example, we replaced a single 12.3 meter section with 30 410 millimeter sections, and you wind up getting a pretty reasonable mesh density on that particular section of Hulk. So we'll do that same thing here, and we'll generate all of these sections and the connections fairly quickly. So I'm going to turn off that section, and I'm going to make a new layer, and we'll call it strakes. And we're going to do this portion of the hull here from 20, 40, 60 to 80. Now the decks are at 5 meter increments here, and you'll see there's a bulkhead here to define an outboard tank that we'll build later, and that's 10 meters off center line. And there's a division in the inner bottom here, which is 5 meters off center line. So the first thing I'm going to do is to grab, and this is another thing that's useful in Rhino, you can highlight a surface, or later on when we have a lot of curves and points, you can highlight it in one view to make it easier to select, and then look at it in another view to know where it is on the hull. So now I know that this is the section that I'm dealing with, and I can just grab all of those surfaces that cross it from this view. And I did that with a crossing window, so I went from right to left, and it grabbed all the surfaces. Now I actually didn't really need that vertical bulkhead. What I needed was the main deck, the hull, and with regards to selections in Rhino, when you select an object, if you hold down the Shift key, you can add to the selection set. And if you hold down the Control key and click on something, you can remove things from the selection set. And a lot of times when we're adding and deleting things here, it can be useful to select a lot of items and then remove them from the selection set. And in fact, we'll be doing that shortly. So to get my curves that I want to generate the endpoints on, we'll grab, actually, we can just go ahead and grab all of these. And then we'll use that section command. So just type section. I know that the lowest point on the hull is right here on center line, and it's a flat bottom. So if I select that, I know I'm at the extreme bottom of the hull. I could also click on this point, and if you hover on it for a little while, when you move away, you see the temporary line restricting motion. So I can use that by hovering on that point and then using that in teleselect, I think, but it holds that a projection of that line, and in this case, straight down. So I can click on that point, and you can also see in the X, Y, and Z in the lower left here, or where the cursor currently is. So I'm exactly at X equals 60, which is what I want, and I can drag up and do a complete section through the hull. And the section command is still active, so I'll go to 80. And if I want to make sure I get everything, I'll move down a little bit, and I'll go up and do another complete section through the hull. And now I can right click to complete the command. And you can see the curves that have been created. They cut through all of those sections. And unfortunately, I created the strakes layer, but I forgot to change the current layer. So when I created those sections, they are on the surfaces layer, but they're still selected. So I can simply go over into the properties tab and move them to strakes. And now I can make strakes my active layer and turn off the surfaces and just deal with these two section cuts through my hull. Now the next thing I want to do is create the endpoints to be imported into Maestro. And you can create regular lines, or you can create polylines. Polylines can have more than just a single segment, but they don't have to. I tend to create polylines and just make them single segment, and it's just a little bit quicker since it's right there and available in the toolbar. Now I have currently, for the object snap, I have end turned on, as well as points, intersections. We don't have any curves, so I don't need center here. Later on, when we're dealing with meshes, you'll want vertex to be turned on for selecting things. And another thing to know about Rhino is that when you're using these object snaps, you can have various ones selected at any given point in time. And if you decide I really only want to select a vertex for my next selection, but you don't want to unclick everything, if you right click on one of these, it temporarily makes that the only selection. And then if I right click on it again, it restores all of my previous selections. If you have multiple types of geometry displayed, your meshes and your surfaces and say some curves, but you're trying to only select vertices from the mesh, then you can very quickly in here just come down, right click, and now it will only snap to a vertex in your mesh, and then come back, right click, and restore all of your regular snap selections. So the first thing I'll do is create a line from one end to the other, and then I'll right click to complete the line. Now that I have that line, I need to make additional copies throughout this whole section. So we've got a couple ways of doing that. The first is a simple copy command. So you can execute a copy, give it a reference point, and then as you start to drag in a direction, it'll move your copy of the curve there. And right now you can see from this viewing angle in the perspective view, it's only letting me drag fore aft and side to side. Now I can select it in one view, but then move it in another. The point that I selected, even though I clicked there, it selected a point on the construction plane. So the construction plane is down at z equals 0, which is why when I come into this other view, you can see it's so far off past the end of the ship. But when I'm in this view, it's very easy for me to drag that vertically. The other thing is that when you're going to move, you don't have to move just graphically. If I type in a value, say 2.5 meters, which is what we're going to move it, I can type in 2.5 and hit enter. and it restricts the distance to 2.5 meters in whatever direction I tell it. Now I have orthogonal still turned on, so it's only letting me move it in 90-degree increments here, but I can move it over in that direction. And when I click, regardless of how far away I am, it's moving 2.5 meters. Now that that operation is complete, I can move graphically to any distance, and I could type in 5 meters. And now I'm restricted to 5-meter increments, and so forth. I'm going to undo that. And another option, and there's only a few here, so you could easily create those manually, but there's also this option to create an array. So I have that line object selected, and I'll go ahead and create a rectangular array from that object. Now this can be in 1, 2, or 3 dimensions. So it asks you how many do you want in the X direction. And you can see this little axis icon shows you which directions are currently X, Y, and Z in this view. So I only want 1 in the X direction. Now I want 6 in the Y direction and only 1 in Z. And then it asks what spacing do you want, and preview is turned on. And you can change the number, how many you want here if you decide 6 wasn't the correct value. But I'm going to go with the 2.5 meter spacing. You get your preview, so I could change the spacing or the number if they weren't right. But this is what I want, so I'll go ahead and hit right click to hit enter and complete the command. So now I have all of these lines. At this end, you can clearly see it's not quite touching the endpoint that I wanted. So I can just click on that line, and when you click on an item, it'll display the control points. So if I click on these other curves, you can see where the control points are for that curve. And you can move those around at will. So if I click on this curve and it displays the control points, and this button in the toolbar is to turn on and off control points for any object. But if you've only clicked on one, or on a curve anyway, it'll display all of the control points. And I can drag that control point around in the X direction. That little red rectangle over it is the scaling option from the gumball. So I can either zoom in, but it's staying in that same location. So I'm just going to turn off the gumball. And now when I grab the control point, I can move it and snap it to the end there. This one's very close, but you can see if you zoom in, it's not quite on it. So sometimes what I'll like to do is just move it away and then move it back, so I know I get that snap to the end point. So now all of these endpoints on the deck are done. I can grab all of these and do a copy rather than creating them all fresh. I will copy from the main deck to the second deck and the third deck and the inner bottom. And then I'll just come in and I'll grab that outer curve because I know it needs to be snapped to the end of the deck here. And to make sure I do that, I'm going to turn the gumball back on and I'm going to drag all those out a little bit away from the hull. So clearly they're not where they need to be. And then I'll grab each one and I'll put it at the end of the deck there, and it'll snap to the, because I have it highlighted, the endpoint. And it'll tell you which one is currently active, what it's snapping to, whether it's snapping to a perpendicular connection, an endpoint, or an intersection. And I know I want to snap to the endpoints, but I can just be careful to make sure it's hovering to the right one. So if I came up here, there's my apparent intersection, perpendicular, but I want the end of the deck there. So if there's too many things in the area, it'll bring up a list like that, so you can refine which item you're selecting. So now I have all of the endpoints for my decks. I still need them on the shell here. And this is where the split command can be useful when you want to split curves. I know I've already created the endpoints at the deck shell intersection, but let's say I want to add 2 endpoints in between each deck. I could specify a height and cut sections through these curves, or I might want to just do evenly spaced between each section in here. So what I'll do is I will use the split command, and I'll just click on this toolbar button over here. And those curves were selected, but I want to split at each of the decks. And now you can see I have separate small pieces of curve selected. So I'm going to grab each one of those pieces of curve, and under the curve menu, there's a command for point objects. And you can create, single points, multiple points, and so forth. But these ones are fairly handy. This mark the start of a curve, mark the end of a curve, or tell it to divide a curve by, and then you can either select a specific length, and it'll divide that curve in increments along the girth of the curve of whatever length you specify, or you can say number of segments. And a quick way to mark both endpoints is tell it to divide the curve by a number of segments and select 1, and it'll mark both endpoints. You can bisect a line by saying 2, or in this case, I want to make 3. So I'll go ahead and say number of segments, and I'll give it 3. And you can see it broke up each individual curve, since I had 3 selected. It doesn't do the total curve. It does each individual one and does that operation on it. So you'll see it created 2 points here, one that belongs to the upper curve, one belongs to the lower curve. Now I have the endpoints that I want to use to create the points to create the endpoints. Again, we can manually create these by clicking on the 2 ends of the polyline and hit return. Or another command that I like to use sometimes, especially if you have a lot of repetitive curves to make, is the curve polyline through points. Now this is really handy when you have a whole series of points that you want to create a polyline through for, say, either creating a beam trace from a mesh, or if you want to just create a temporary curve that you can extrude from a bunch of mesh vertices. But if we say polyline through points, then in the body plan view here, I can just drag a window across all the points I want in my curve and right click to create it. And you right click again to finish the command. And then I can right click an additional time to start the command again. Drag a window, do 2 right clicks, and then an additional right click to start the command. And you just keep repeating this process to generate a lot of these endpoint curves. You can pre-select and then just hit the right-hand mouse button to execute the command. And then it's just 2 clicks. So it'd be pre-select and 2 clicks to execute command and complete the command. So now I have the endpoints on my side shell. I still need them on the bottom here. So I will select both of these curves and to create the endpoints here, because I want them directly below. I don't want an even girth here, but I want them to be directly below the endpoints on the deck above. So we'll go under curve from objects section, or we could have just typed SECT and it would have found it. Now, because I've got an end view here, I can't really see the locations of the endpoints that I want to select, but I can select them in this view and then trace it down in the body plan view. And you can see I got my points on either curve. So I'll go to the next one here, go straight down, go to that next one, go straight down. And I can use the end of this line to generate my other curve there. So now I'll go in here and on these 2 endpoints and a polyline on the end of those 2 lines. And for these, I can use that curve through or polyline through points again, but that's not the last command that I executed. So I can't just right click to execute it again. So here's another little trick in Rhino, is that up in the command bar up here, if you right click on the command line, it brings up the last 10 recently executed commands. So I can just go down through this list, and then these are fixed at the top, this enter, copy, and clear. But then below it, you get the last 10 commands that you've executed. So I can see I still have in the listing here polyline through points, so I can select it and then right click to complete. We'll select the next two, right click twice, and the last two, right click twice. So now I have all of my endpoints for all the strakes in this module of the hull. I no longer need any of these points, so I can do select points and then delete. And I don't need these curves at the end. So the easiest way to do that is a regular window selection at one end, delete those curves. And they look like the polylines that I want to create to tell the program how to connect things. But if I click on them, you can see the density of these curves is a lot greater than just the endpoints of those polylines, which is what I really need, is a polyline consisting of only the points at those ends of the endpoint curves. So I can delete all of the curves from this end as well. And now to generate those polylines, we'll highlight all of these curves and we can turn on the control points. To use that command, polyline through points, we don't need to have actual points available. They can simply be the control points that we're using. And so for the main deck here, I'll drag a window across all of these points at the top and then say polyline through points. And for the next one down, I know it's the third point below, but if I wasn't sure or I had a much denser collection of points here, I could highlight one in this view. So it'd be identified in this view. And actually, when I zoom in, I don't know why those are slightly off. I'll have to look at that. Let's take a quick measurement here. That one is at y equals 12. That is at 12.01. So I think when I dragged that point back in and it snapped to an end, it must have been the end of a line segment that was very close to that deck end, but not exact. So here's where I might want to use that set point command. So I'll say set point, and I'm going to reset the Z value. And I can type in the value, or I can simply click on another similar one and it'll take the Z value from that and match it. So now let me reselect all of these lines. We turn on the control points and then grab those points and do polyline through points. And now we have that deck created. Go down 3 points and do the next one. And then down at the bottom here, grab all of those and again, polyline through points. Now, from the surfaces layer, if we turn that back on temporarily, we can see right in here, we need a vertical bulkhead. So I'm going to grab that point to highlight it so that when I turn this off, I can see where that was. So I know I want a polyline from this point to this point, and we can do polyline through points. And these two will define that small bulkhead in the inner bottom. So we have everything but the shell completed. So the easiest way to do the shell, and this is what I was referring to earlier, where you may want to do a larger selection and then remove from the selection. So we can grab everything at this end, which is including both the control points from those curves as well as all of the polylines that we just created. I will come down in the body plan view here, and you hold the control key down, and we'll do a crossing window. So we start at the upper right and move to the left. We unselected all of the curves and control points portion, and then we'll unselect this top of the inner bottom here, and now we're just left with all of these points on the shell. So then we can say polyline through points. And now we have our polylines connecting all of the endpoints. The other thing we want to check is the direction. So if we highlight those curves, under the Analyze menu, there's an option to display direction. This also applies to surfaces and the meshes, and it'll display the normals for those, but for purposes of the curve, it's simply the direction, start to end of the curve. And you can see they're fairly uniform. All of the decks are going from center line out. The vertical bulkheads are going from top to bottom, but my shell is going from bottom to top. Now, this direction is going to determine which side the frames get created on. If the inboard to outboard, the frame might be on the top, versus if we reverse the direction, the frame will be created on the bottom. So at the very least, we want to be consistent. So if we know, this direction is going to create it on the bottom of the deck, then we need to be going clockwise on the hull to get it to be created on the inside. So we can just click on that hull curve and it'll reverse the direction of that one curve. Now there's also an option up here to flip all, where it'll just reverse the direction of everything that's been selected. Or you can just click on one individually to just change the direction of one item. So they're at least all in a consistent orientation. If we got it wrong, we can go back and do it again. And the next thing would be to run that script. To run scripts in Rhino, you go under the Tools menu, and then Rhino Script and Load. Now, I've run some of these before, so they're already available in the list that I can just click on one and you say Load, and it'll go ahead and run. But that's not one of the ones that I've run recently, so I need to hit the Add button. So I say Add, and this is a different Rhino Scripts area. That was in my Documents and Settings. So let me go into the Maestro Data, Models and Samples, Rhino Scripts, and we'll load this Export Maestro endpoints. Now that it's available in the list here, I can just say Load, and it'll ask to select all of the nodes and endpoints that I want to export, and that's all of the longitudinals here. And then as an option, you can select the polylines defining how they should be connected. So I'll grab all these polylines at the end that we just created. And we'll call this breaks.text. And once we're in Maestro, if you go under the File menu, Import, and you'll select the polygon file format, which will allow you to select both PLY files and text files. It'll bring up both. It will know the difference when it reads them. We just say go ahead and open, and we'll use make it a global model rather than a fine mesh. And I like to leave the transform nodal coordinates turned on. Now we were working in meters, so we're good with leaving this as meters for our units. We'll say OK, and there's our whole section, 60 to 80. Now this strake was a little large, so we'd probably subdivide that one. We could have done that either in Rhino, or it's easy enough to split a strake here. So we can do that here. We can split it again and then line those up with the other strake points if we want. It's a flat bulkhead, so it's nice and easy to manipulate the heights of that one. But then you can see strake element, the entire length of the module. So we'll come into the parts menu, highlight strakes, go into sections, and instead of one 20-meter section, remove that, and we'll add 20 1-meter sections and modify. And then we're starting to get into a reasonable looking model. And since this was a fresh model, we don't have any beams or plate defined, but we can just quickly run in here and we'll go into the library, create a I just want to make a quick frame in here. So that we can grab, and we can do all of the straights actually. And use the group modify properties, and we will change the frame to that value. And we have to turn visibility back on. So we got the frames right. They were on the inside of the hull and the bottoms of the decks. So that direction worked for what we wanted. If it didn't, we could have, simply, reversed the normal on all of these in Maestro. That would have fixed it. Or we could have come back into Rhino and reverse the direction on these curves and re-export. But anyway, that is the quick way for generating the straight-based model and getting it into Maestro from your 3D geometry.